Let's start with random experiment. A random experiment is an experiment whose outcomes are unpredictable. Like when we are tossing a coin, the outcome can be either head or tail. When we roll a die, the outcome can be either 1, 2, 3, 4, 5, 6. So any number between 1 and 6. Similarly, few other examples like customers in a day at a restaurant, lifetime of a bulb. These are few experiments whose outcomes are unpredictable. So we are calling it random experiment. Next is random variable. A random variable is a variable that takes different values based on the outcome of the random experiment. So if a random experiment is rolling a die, then the random variable can be a variable that can take any value x, where x can be anything between 1, 2, 3, 4, 5, 6. So there are two types of random variable possible. Like one is discrete random variable that takes specific countable values. For example, the number of heads when you flip a coin 5 times. So if we flip a coin 5 times, we can get head any number of times between 0 and 5, right? So this is a discrete random variable because we can count it. Continuous random variable takes any value within a certain range. For example, the height of a student in a class. So it could be any value within a possible range. Of course, the human heights have a possible range, but within that range, the height of a particular student can be anything, right? So this is a continuous random variable. Now, in short, what is the difference between random experiment versus random variable? Random experiment is the experiment, like rolling a die. So this is the random experiment. But the random variable is a variable that can take any value between 1, 2, 3, 4, 5 and 6. This x is a random variable. So x can take any value x where x is belongs to 1, 2, 3, 4, 5, 6. An event. Event is a collection of possible results from a random experiment. Like when we are rolling a die, the event can be getting a 6. When you are tossing a coin, the event can be getting a head or getting a tail, right? One more event can be when we are rolling a die, getting even numbers, right? So when you are rolling a die, the even numbers are 2, 4 and 6. So one event can be getting this 2, 4 and 6. Next is sample space. Sample space is the set of all possible outcomes. Like when you are tossing a coin, the outcome can be head and tail, right? So the set of all the possible outcomes, head and tail, this is the sample space here. When you are rolling a die, the sample space can be any number between 1 and 6. Now, when we are drawing a card from a deck of 52, let's say we are drawing a card where we have 4 suits, right? Diamond, clubs, hearts and spades. And each suit we have 13 cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So basically in each suit we have 13, 13, 13, 13 In total, we have 52 cards. So the sample space here is a set containing all these 52 outcomes. Now, what's the sample space for tossing two coins? When you are tossing two coins, the first coin we flip, we can get either head or tail. Next time also we are flipping one coin, then also we can get head and tail, right? So we will try to draw a tree diagram here. Let's say first time we got head or tail. So if we first time get head, then second time we can get again head or tail. If we get tail first time, then also next time we can get head or tail. So we can either get head first time, head second time, head first time, tail second time, tail first time, head second time, tail first time, tail second time. So these are the all possible outcomes. So the sample space will contain all these possible outcomes. Next, if we are tossing a coin 3 times, so similarly we'll draw the tree diagram here. First time we got head and tail, second time also we can get head and tail for each of the first outcome. Then for each of the second outcome also we can get head or tail. Like it's basically if we have 3 coin or one coin only we are throwing multiple times, so in each of the time we can get either head or tail, right? So the possible outcomes, let's see, we can get head first time, head second time, head third time, head first time, head second time, then tail third time, head first time, tail second time, head third time. And this way, if we just list down all the possible outcomes, this comes HHH, this is HHT, this is HTH, this is HTT, this is THH, this is basically THH, next is THT, then TTH, then TTT. So we have total 8 outcomes in the sample space here. When we are rolling a die twice, so if we have one die, right, if we can get 1, 2, 3, 4, 5, 6, right? Similarly, we have one more die. There also we can get 1, 2, 3, 4, 5 or 6, right? So first time we can get any of the 6 output, and for each of the first outcome also we can get, again we can get 6 output. So in total we'll have 6 plus 6 is 36 outcomes in the sample space. Now the probability. Probability is chance of a particular event occurring. So if we are tossing a coin, the event can be getting a head or getting a tail, right? So how do we calculate the probability? The chance of a particular event occurring is we divide the number of desired outcomes by the total number of possible outcomes. So desired outcomes in the event and total number of possible outcomes in the sample space. So this NA, probability of A is we write as P of A, and N of A is the number of outcomes in the event A. N of S is the number of outcomes in the total sample spaces. So getting a head, if this is the event, then the probability will be uh, getting ahead. We have one possibility and total sample space is 2, right? Sample space is head and tail, and we getting ahead is basically one outcome. So the probability is half. Similarly, if we are, let's say we are rolling a die and the event is getting even number, basically 2, 4 and 6. In that case, probability will be 3 out of 6, because 3 is the outcome, 3 is the number of outcomes in the event and 6 is the number of outcomes in the sample space, which will also be 0.5. Now probability of any event can be between 0 and 1. So if it is 0 means it will never happen. The event will never happen. If it is 1 means it will always happen. Like with 100% probability. So we show the probability as a number between 0 and 1, and also sometimes we show it as percentile, like percentage, like this is 50%. So there are two notation to define the probability. One is the event notation that we already saw. P of A represents the probability of an event A occurring. P of A is P of even number is basically 3 out of 6, which is half. There is one more notation called random variable notation that I'm just discussing here. Will not be continuing this random variable notation for the next videos. We'll again discuss about random variable notation later in the advanced part of the playlist. Random variables are usually denoted by uppercase letters like X, Y, Z, and so this is the random variable here, X, the capital X. The value that a random variable can take is denoted by lowercase letters like X, Y, Z. So this is the this is the value that random variable will take, and X can be 2, 4, 6 for this event even number, right? So if X is 2, 4 or 6, any of these three, then the probability of that is 1 by 6. Is basically if when this random variable X is 2, then also probability is 1 by 6. If it is 4, then also probability is 1 by 6, 6. And when the value is 6, then also probability is 1 by 6. But the probability of for any other X values is 0. Now we'll see few examples. Uh, if 3 fair coins are flipped, what is the probability of getting at least 2 tails? So 3 fair coins are flipped. So if for, first time we flipped one coin, then we got head and tail. Second time also for each of the first outcome we can get head and tail. And then for each of the second outcome we can again get head and tail, head and tail, head and tail, head and tail. So basically we have 8 possible outcome. T T H T T T. So our event is getting at least 2 tails. So let's see which all outcomes satisfy this criteria. This has 2 tails. It has 3 tails actually. This has 2 tails. This has 2 tails. This doesn't. This has 2 tails. This doesn't. This doesn't. This doesn't. So basically we have 4 possible outcomes in the event, and we have total 8 outcomes. So basically our probability is 0.5, or we can write it as 50%. If rolling a die What is the probability of getting a number that is less than or equal to 5? If we are rolling a die, the sample space is 1, 2, 3, 4, 5, 6, right? And the event is getting a number less than or equal to 5. It's basically 1, 2, 3, 4, 5. So what is the probability of this event is number of outcomes in the event and number of outcomes in the sample space, which is 5 out of 6, which I believe is 0.8333, that is 83.33%. In a standard deck of card, 52 deck of card, what is the probability of selecting a queen? If in a standard deck of card we have hearts, diamonds, then clubs and spades, right? So each of this suit will have 13, 13, 13, 13 cards, and in each suit will have one queen. So in total we have 4 queen out of 52 cards, right? So our probability in this case will be 1 out of 13, which comes around 0.0769, and that also we can write as 7.69%. Next, there are 200 birds in a zoo. 70 birds are male with brown eyes, 100 birds are female with brown eyes, 20 birds are male with blue eyes, and 10 are female with blue eyes. Okay, what is the probability of selecting a female bird at random? What is the probability of selecting a bird with blue eyes at random? Okay, how do we visualize this? I will draw a chart or table, contingency table. Basically, let's say this is the gender and this is the color of eye, right? So here color of eye basically can be brown eye or blue eye, and here we have gender, it can be male or female. So there are total we'll have 200 birds, right? So 70 birds are male with brown eyes. So male with brown eyes, there are 70 birds. Then 100 birds are female with brown eyes. So female with brown eyes, basically here we have 100 birds. Then 20 birds are male with blue eyes. Male with blue eyes. So we have 20 birds here. Then 10 birds are female with blue eyes. Female with blue eyes, we have 10 birds, right? So if we see, the number of male birds are 70 with brown eyes, 20 with blue eyes. So in total we have 70 plus 20, 90 male birds. So this is the male birds, right? We have 70 brown eyes, 20 blue eyes. So in total we have 90 male eyes. Female eyes, let's see, we have 100 with brown eyes, 10 with blue eyes. So basically we have 110 female birds. Next is the brown birds, right? Sorry, birds with brown eyes. So we have 100 plus 70. So we have 170 birds with brown eye. Next is birds with blue eyes. So we have 20 plus 10, 30 birds with blue eyes. So now if we just calculate the total here, you see 110 plus 90, this comes 200. Also 170 plus 30, it comes 200. Because here we are calculating all the male birds, here we are calculating all the female birds. In total we are getting 200. Here we are calculating all the birds with brown eyes. Here we are calculating all the birds with blue eyes. So if we are getting 170 with brown eyes, 30 with blue eyes. So in total 200. So now our question is, what is the probability of selecting a female bird at random? So you see, this is the row where we have female birds. Female bird with brown eyes, female bird with blue eyes. So we have in total 110 female birds out of 200 total birds, which is 11 out of 20. The probability of getting selecting a bird with blue eyes. So now we are not considering the gender, we are just seeing blue eyes, birds with blue eyes. So we have 30 total birds with blue eye, right? So 30 out of 200. So 30 30 birds with blue eyes and 170 birds with brown eyes. So the probability of birds with blue eyes at random is 3 out of